In the last class, we looked at what a mapping or a function is, and we explained how to identify a mapping or a function. So now, today, we'll be looking at types of mapping or function. Types of mapping or function. So the first type of mapping or function that we have is the one-to-one or injective mapping. So now, looking at the name one-to-one, what does one-to-one mean? Now, this is just the concept of this. Let's have a function or a map from x to y. You know, we explained it in the last class that if you're having a map from x to y, x is the domain, y is the what? Is the codomain. Now, given a function from x to y, suppose I take two elements inside x. If I take two elements inside x, now if the images, okay, look at this. I take x1 and x2 inside x. What will be the image of x1? The image of x1 will be f of x1. What will be the image of x2? The image of x2 will be f of x2. Now, this is just the injectivity part or the one-to-one. Now, if two images are equals to each other, then the pre-images will be the same. If two images are equals to each other, the pre-images x1 and x2, they are going to be the same. So if you have a condition like this, then we say it's going to be one-to-one. Let us have a diagram to represent that. Let's just take an example to represent that. Look at this. We have x, then we have y, right? So this is a function from x to y. Suppose we take the element in the domain as, let's say, a, b, c, d, and this will take element as e, f, g, h, I, let's just say j. So now look at this. A is mapping to, let's assume a map to e, let's assume c map to I, let's assume d map to f, then b to g. So look at this question. So now, you know, I said suppose we have two elements inside the domain. If the images of the two elements are equal to each other, then the pre-images will be the same. So look at this now. We have a, b, c, d. A has image e. That is, what this means that it means that f of a equals to e. B has image g. This implies that f of b equals to g. Cool. Now, then the image of c, f of c equals to I. The image of d, f of d equals to f. Now, in this question, if you notice the images that you have, the images here are just e, g, I, f. That is, f of a equals to e, f of b equals to g, f of c equals to I, f of d equals to f. You know, we talked about range and image. So I told us that the range is a subset of the codomain. That is, it is a set that contains, like, it is a set in which all the elements in the set can be found in the codomain. So now look at this now. A is a pre-image, the image is e. B is a pre-image, the image is g. C is a pre-image, the image is I. D is a pre-image, the image is f. So from what I have here, now suppose I have a and b inside this domain. A and b, are they having the same image? When you notice this, e, g, they are not the same. E is different from g. When you look at this too, I is different from f. So since two images cannot give us the same pre-image, so we said it's an injective mapping or a one-to-one mapping. That's why it is one-to-one. A mapping to e, b mapping to f, c mapping to I, then d mapping to f, like that. Okay, let us let me try to reframe this question. Let's try to reframe it. Now, let's look at this. Can we say this is a one-to-one mapping here? Let's look at it. We notice that the image of A is E, the image of B is G, the image of C here is what? Is E. Image of C is E. Two images. But we notice that A is not equal to C. You know that A and C, they are both elements in the domain. So since A is not equal to C, but these two images, normally when we look at this is a map because A has a unique image, C has a unique image E. But is it a one-to-one map? It's just like these two elements not equal to each other. A is not equal to C, but they have the same images. So therefore, this illustration or this example is not a one-to-one function. Let us have another case. Let's say we have a case like this. This is just a diagram. Let's have a real question. Let's say a function from natural numbers to real numbers defined as f of x equals to x plus 3, where x is an element of natural numbers. So I'm very sure many of us will notice that I wrote something like this. This n and this slash means set of natural numbers. And from MTS 101, set of natural numbers are just counting numbers from 1, 2, 3 all to infinity. Now we have R. R here is set of real numbers. Real numbers is a superset, is a set that contains natural numbers, integers, rational numbers, irrational numbers, and any numbers except complex number. Complex number is just the bigger superset that we have there. Now I want to show that we have a function like this. What I want to do is I want to show that is f a one-to-one function or is f injective? Now how do I show if f is injective? This is what I'm going to do. Solution to this question. Suppose I take two elements x1 and x2 inside. You know, when I first wrote this, I wrote something like this. I said f from A to B. Is it okay? I think I used from x to y. And I say suppose I take two elements. Suppose x1, x2, the element in x. Suppose I take two elements in x. Now, what is the image? What is the image of x1? The image of x1 is f of x1. And from what we have here, f of x is equals to x plus 3. Since, okay, before that, let's just write this. Since f of x equals to x plus 3, the image of x1 will be what? F of x1. Now, when we have f of x1, we have, since we know f of x equals to x plus 3, so this implies that f of x1 will be equals to x1 plus 3. That is the image of this. Then let's look at the second guy. The image of x2. What will be the image of x2? That's what? F of x2 equals to what? X2 plus 3. And for it to be one-to-one, I said if f of x1 equals to f of x2, then x1 will be what? Will be equals to x2. But in this case now, we have f of x1 as what? That is, f of x1 is what? That's x1 plus 3 equals to, we are supposing, if f of x1 equals to, if x1 plus 3 equals to x2 plus 3. That's what we have here. Now, For me to have x1 equals to x2, from what we know, from the knowledge of algebra that we know, for us to simplify this further, we can just subtract 3 from both sides. Subtract 3 from both sides. So if I'm subtracting 3 from both sides, that's going to give me x1 plus 3 minus 3 is equals to x2 plus 3 minus 3. Okay, we know here, let's continue it here. So this will give us x1 equals to, because 3 minus 3 is 0, 3 minus 3 is also 0. So this means that x1 equals to what? X2. And from what we have here, we say if f of x1 equals to f of x2, then x1 will be equals to what? X2. So since f of x1 equals to f of x2 implies x1 equals to x2, therefore f of x equals to x, f of x equals to x plus 3 is a one-to-one mapping or function, anyone wants to call it here. So I just use this illustration to check it. Now if I want to just use the normal taking of elements inside my domain and codomain, recall that our domain here is natural numbers. We say f is a function from natural numbers to set of real numbers. Now if I take any element here and know it is defined as f of x equals to x plus 3. Now if you take any element here, is there going to be, am I going to have two images that are the same, in which the pre-images we map to it? Okay, what that means is that if I take one inside natural number, suppose I take one inside natural number, if x equals to 1, f of 1 will be what? 1 plus 3, which is equals to what? 4. If I take 2 inside natural number, let's assume I take 2, have this in mind, I cannot take minus 1 from my domain. Natural numbers, they are counting numbers from 1, 2, 3 all to infinity. I cannot take minus 1, I cannot take minus 2. So if I take x equals to, let's say x equals to 10, it means that what? F of 10 will be what? Will be 10 plus 3. And 10 plus 3 will give us what? 13. You notice that 13 here and 10 here, they are different. 13 here and 4 here, they are what? They are different pre-images. They are different images. Same as 1 and 10. 1 and 10 are different pre-image. So this is just how to show that a function is a one-to-one function. You can follow us for more examples.